Today we're going to learn about complex numbers, which are also called like the imaginary numbers. So if we recap the type of numbers that we know natural numbers, whole numbers, rational numbers, irrational numbers. Today we're going to take a look at imaginary numbers, which you may remember from Math 2, I believe. So these are cursive I's, but the I stands for imaginary. So the imaginary unit is I. Again, it's a cursive I, but it's imaginary unit I. I squared equals -1. That's what you need to remember. And you also need to remember that I equals the square root of -1. Hopefully this is easy to remember because when you square a number, it always should give you a positive number. But I square is the only number that when you do square, it's a negative. So I squared equals -1. And I equals the square root of -1. Down here I have some complex numbers. This one has a real part. Most of the time we're very familiar with looking at the real part of the problem, but it also can have an imaginary part. So this is a complex number because it has a real part to it and an imaginary part to it. So 5 is the real part and 2i is the imaginary part. So this number is 5 plus 2i. Most of the time, we only work with the real numbers, whether they be fractions, decimals, whole numbers, integers. Most of the time, we only work with pure real numbers. Very rarely do we work with pure imaginary numbers, but they're out there like this 5i. So the reason this comes up is, let's take the first method that we did way back when, solving a quadratic equation by graphing. So if we solve it by graphing, we know our solution is where it crossed the x-axis. It can cross the x-axis twice. So if I write down here, one of my options was it crossed twice. Boom, boom. Another option that we had was it can cross once. So boom, down there. And then the last option that we took a look at is what if it doesn't cross at all? So if it didn't cross at all, at that time, I told you to say no solution or no real solution. So no real solution. So that's what I told you to write at the time. But today, by the time we're finished, you'll know how to keep going and get the imaginary part of our solution. And I also drew a much better, neater graph up here as well. This parabola does not cross the x-axis. So we will stay no real solution. But by the end of today's video, you will know how to keep going and find the imaginary solution. So this parabola does not cross the x-axis, so there's no real solution, but there is an imaginary solution. And we are about to find that out right now. So I squared equals -1, and I equals the square root of -1. So that is our take-home part. So bubble, highlight as you take notes wherever you may be. So I want you to take a sheet of paper, and we're going to make a foldable. So I want you to divide it into 4 different sections, like I have here. So I folded it long with hamburger hot dog. I folded it 4 different ways. Put a little circle in the middle for complex numbers. I wrote our definition. I squared equals -1 and I equals the square root of -1. We're going to go through 4 different sections. I'm going to show you how to add and subtract imaginary numbers. I'm going to show you how to multiply imaginary numbers. I'm going to show you how to divide imaginary numbers. And then we'll end with solving equations. And I did already put 2 equations in there. So you can put this here and pause it, and that way you can go ahead and copy and get your paper and stuff all set up, and then we will be ready to rock and roll. So let's start with adding and subtracting. Adding and subtracting these imaginary numbers, keep in mind, I's for imaginary. Adding and subtracting these imaginary numbers simply means you add and subtract like terms. You put the real part of the problem with the real part of the problem. You put the imaginary part of the problem with the imaginary part of the problem. So looking up here, I see that real plus real, and then imaginary plus imaginary. How do I know it's imaginary? Because it's got an I to it. So 3 plus 2 is 5. And 5i plus -4i is 1i. You do not necessarily need the 1 in front of the I. I'm just writing it there in case you need it, but you don't need it. If you just want to put 5 plus I, we speak in the same language. So 3 plus 2, boom, 5i minus 4i was 1i. Short and simple, to the point. Same thing with number 2, imaginary plus imaginary and real plus real. So 7, 3, and then this with this. Calculator, mental math, whatever helps you out there. 7 minus 3 is 4. Negative 6i minus 10i is negative 16i. When you type that in the calculator, if you're doing the subtraction there, you would type in negative 6 minus 10. So 7 minus 3 is 4, and negative 6i minus 10i gives me negative 16i. Let's try one more. So down here, I only have one part that's real, and that's the 2, and that's okay. And then I have these imaginary sections here. So the 2 is going to come straight down because nothing goes with it. And negative 4i minus 2i is negative 6i. And that is all there is to it for adding and subtracting your imaginary numbers. That's all there is to it. You add or subtract the reals together. Well, you add or subtract the reals together, and then you add or subtract the imaginary numbers together. So that's all there is to it. So that's the adding and subtracting. Let's move on to multiplying. All right, so I got a multiplying one down here. We probably will do 2 examples in this box. So I only wrote one to see like how I was going to start writing it. But just for your space wise, as you get started, we probably will do 2 in this box. If we are multiplying, this is 3 plus 2i times negative 2 plus 4i. These are 2 binomials. I multiply these just like I would do the box method, or I would do distributive property. So I multiply these normal, no different than if it was 3 plus 2x and negative 2 plus 4x. I treat it all the same. I like doing box method. So 3 plus 2i, setting up my box here, and negative 2 plus 4i. And let me put my plus sign in the front here. So 3 plus 2i, negative 2 plus 4i. So I'm doing the box method. No different than if we were doing 3 plus 2x times negative 2 plus 4x. So we're going to multiply these. So negative 2 times 3, negative 2 times 2i, 4i times 3, and 4i times 2i is 8i squared. I did a box method. Now we're going to go through and combine like terms. Before we combine like terms, I'm going to simplify this I squared. So our definition over here in the center of our paper, I squared equals negative 1. So I am going to replace this with negative 1. So this box now becomes 8 times negative 1, which is negative 8. So I squared equals negative 1. So that means what I circled right here, this I squared, get rid of that I squared, replace it with negative 1. And 8 times negative 1 is negative 8. Now we can combine like terms. So negative 6 plus negative 8 is negative 14. Negative 6 plus negative 8 is negative 14. I combine like terms. And then these like terms go together. 12i minus 4i is 8i. And that is our answer. That's our final answer. So we treat this no different than we do a regular binomial that we know how to multiply, box method, or distributive property. Now I'm going to do another example in this same space. So hopefully you left room to do another one. This time we're going to multiply 3 minus 5i times 3 plus 5i. So we're going to multiply 3 minus 5i times 3 plus 5i. So distributive property or box method, whatever helps you out. Since I did box method over here, I do know a few of you like to do distributive property. So I'm going to do distributive property for this one over here. So if you're going to do distributive property, it's 3 times this binomial and then negative 5i times this binomial. So 3 times 3 plus 5i. And then negative 5i, writing in colored pencil here, sorry. 3 plus 5i. So ignore my little mistake there, writing in colored pencil, no eraser. So I did 3 times 3 plus 5i and negative 5i times 3 plus 5i. So I took this first one and I broke it up. 3 times the second binomial and negative 5i times the second binomial. So since I did the first one using box, I did this one doing distributive property. So 3 times 3, we're going to go through and distribute. 3 times 3 is 9. 3 times 5i is 15i. Negative 5i times 3 is negative 15i. Negative 5i times positive 5i is negative 25i squared. So I did distributive property over here. I did negative 5i times everything. I did 3 times everything. Now we need to combine like terms. 15i minus 15i cancels out. So let's cross it out. It goes bye-bye. So now I have 9 minus 25i squared. Our definition, I squared equals negative 1. So I can get rid of this I squared and make it be negative 1. So I can get rid of this. I'm making a substitution. Okay. This is now negative 25 times negative 1, which is a positive 25. Get rid of I squared, make it be negative 1. And negative 25 times negative 1 is positive 25. Now my problem is 9 plus 25. And 9 plus 25 is 34. So notice it canceled out, but that's okay. So this one, I had a real part and an imaginary part. This one, I only had a real section, which is okay. Nothing wrong with that. We had the imaginary section that canceled out, and that is quite okay.